Hello everyone, I hope you enjoyed the video in tensors. Now moving on to the third video in this series, and here we're going to study about data loaders. So PyTorch has two modules called datasets and data loaders. Data loaders is essentially used, like it's very trivial, right? The name suggests what it does. I mean, it allows you to load data in a manner which is acceptable by the PyTorch training function. There is no definite training function, but the way we push data into a training function is by using data loaders. And datasets is a module which contain a lot of open source datasets. So we're going to explore it in this video, and we're going to play around with the MNIST dataset. We'll be primarily choosing the Fashion MNIST dataset, which contains a lot of apparel images apparently. So we'll see how to use data loaders and what kind of functions are present in data loaders. And so let's get on with this video. We are inside our VS Code IDE, so we will import some of the important libraries. Torch will be imported, of course, and then we have data set, which comes from torch.utils, and then data sets, that's data sets with a small d, and it's part of the Torch vision library, which we installed along with Torch in the first video, and it is used for a lot of computer vision utilities. We also have pyplot from matplotlib, which we will be using for visualizing our images. And then at the end, we also have Dataloader, which is kind of a iterator for the data sets that we create, and we'll be talking about it later as we progress through the video. Let's go inside the datasets library and see what it consists of. The datasets class inside Torch Vision has an enormous corpus of open source datasets. These datasets range from the extremely smaller ones such as MNIST to larger ones such as ImageNet, Flickr, 8K, and so on and so forth. We will be using the Fashion MNIST for our use case. So Fashion MNIST is actually a derivative of the MNIST, the only difference being the kind of images that it contains. In the MNIST, we actually have images of whole numbers from 0 to 9, but in Fashion MNIST, these are actually apparels. As you can see in the classes, we have t-shirt, trouser, pullover, etc. So we have the mirrors and the resources, essentially the files, the train test files, which we'll be using from this dataset. And we also have a list called classes, which is essentially the label for this dataset, and it contains, as you can see, different apparels and footwear labels. So now let's go inside the MNIST class, from which the Fashion MNIST has actually been subclassed, and as you can see, it is again subclassed from something known as the vision dataset. And MNIST here contains the root, which is a string to the path of the core MNIST dataset, as in the image files in a compressed format. Of course, we have download. So if we want to download the dataset, then we'll pass it as true. And then we also have transform and target transform, which we will talk about later. Essentially, these are transformations that can be passed in order to transform or run some operations on the image of the training set itself. For example, here you can see it's transforms.random crop. If you want to crop the training image, then you can do that as well. And these are some of the defined names for the training and test file, essentially the PyTorch training and test files. And there are these different properties which return some data points related to the training and test files that we have. Now, if we go inside the vision dataset from which MNIST has been subclassed, you will see that it is a base class for pretty much all vision datasets which are present inside the datasets library. And as you can see, it contains the get item function. The get item is essentially used to fetch a particular item from that entire dataset. So for example, if you have a dataset containing 1000 images, then the get item is supposed to return you an image based on the index that you pass. So for example, if you do a get item, if you do a, let's say you have an example dataset, and which is an object of the vision dataset, then you can do an example dataset of 0, and it is supposed to return the 0th indexed data point from that particular dataset, and so on and so forth. Now let's go back to the MNIST class which is using vision dataset. Let's go down and see what it contains. So as you can see, this is the init function containing a function called to check legacy exists. So it actually checks if the files pertaining to the MNIST dataset has they been already downloaded or not. So even if you pass download is equal to true, it will check that in a prescribed path. If the file is already present, the train test, and it meets the requirements, check some values and everything, then it will actually not download it again. So it checks both the image files as well as the targets, the label files that are present. And then you have the get item, right? So what the get item does is it is again overriding the base function which is present inside vision dataset. So essentially, as I mentioned, it is supposed to return an item corresponding to a particular index. So here you can see that self.data is actually our list containing all the images, and self.targets is the list containing the labels, right? So when we pass an index, it will be returning an image corresponding to that index and also a label corresponding to it, right? And we also have transform and target transform. These are parameters passed in the init itself. So transform is part of the Torch vision library, and it is used to transform an image. And then we also are passing target transform. This is being passed so that we can run some manipulations on the target also. In our case, the target is an integer value, which is a label, of course. But then if needed, we can run some manipulations on the target as well. Now coming back to our original notebook, we will go ahead and prepare the Fashion MNIST dataset, and we will put down the steps which will help us to do so. So let's get on with it. Cool. So I am initializing my training datasets. So it's Fashion MNIST from datasets, and we will be passing in some of the values. So the root will be data, essentially. This is the folder in the current working directory, and we want the training split, hence we're passing train is equal to true, download is equal to true, because we will be downloading the data from the mirrors specified. And we are passing transform as 2 tensor. So as you can see, the dataset is getting downloaded. So 2 tensor is actually the transform that we want for our training data points. Essentially, it is going to convert the image that will be loaded into a tensor value. We will be copying and pasting it and replicating the same code block for the testing dataset, and we will just change train to false, and that's going to download the testing split. As you can see, it's done. So the next step would be to go ahead and visualize what the training data object actually consists of. So we're gonna just go ahead and call training data with index 0, and as you can see, it is actually returning a tensor. So this is a tensor containing actually the image, and it also consists the labels. So now as I pass 1, it returns another set of values. So the shape of the tensor is actually 2 cross. Let's check the length of the tensor. So this is supposed to give you the length of the entire training data set. So as we already know, MNIST consists of 60,000 images. So that's the training data set that we have. Now we can also check the size of the test data set. So here we go. We have 10,000 images in our testing set. And next, let's go ahead and check the shape of some of the constituents of the training data set. So if we go ahead and do a training 0.0, we see that it's a tensor, right? And now if we actually go ahead and print the shape of it, we're going to see that it's a image. It's a tensor value 28 cross 28, but it's actually an image. It's a 3-dimensional value, but as you can figure out, it's a single channel image. So that's what it is. Yeah, so that was the error. Actually, it was not a tensor, so it's an integer value. So there are 2 values, one, the first being the image, and the second being the label which was returned. So in this case, for the 0th index, we have the 9th label, right? So that is what we got from the get item call as we pass the index. So now we'll go ahead and actually plot the entire data set. So let's go ahead and do that. This is actually from the example that's present on the Torch Vision website, or I would say the PyTorch official documentation. Apparently, I believe that this writing down the code and actually going through it line by line through the nitty-gritties and the complexities that are present in the datasets library will actually give us a holistical view of what is actually happening underneath. And yeah, so we will also be loading a custom dataset that's gonna come later in this video. But for starters, let's see what PyTorch has to offer us. Yep, so we'll be using Matplotlib primarily for this visualization. First thing to do would be to create a figure, and here we are creating a figure of size 8x8. So I guess that should be enough to plot the images that we have. And next we are going to specify two values, columns and rows, because the idea here is to plot a grid of 9 images and iterate over that that entire length and draw the images, right? So the thing we will do is first choose an index, and we'll be using the torch.rand int function in order to do that. This is the function that we learned in our previous video. Here we are passing the lower range, which is 1, and the length of the training data as the maximum range, because we want that entire length of the training data. The size is 1 because we want a integer number, and we also do a dot item in order to get that integer out from the tensor. If you don't pass dot item, it will actually return a tensor. And then we pass an index to training data, which we did in one of our previous steps. That actually allows us to fetch one of the items from the training data dataset, the Fashion MNIST dataset. And as you can see, for the 9 iterations, we have different pairs of image and labels. The images are actually 3-dimensional tensors, which are single channel. The next step would be to plot these, and the function that we'll be using is add subplot, and then we're going to just call plt.imshow and plt.show in order to do that. So let's go ahead and see what it looks like. Oops, it seems that we have an error. All right, so we cannot plot a 3-dimensional image, so we will have to go and use one of the functions that we studied in a previous video, which was squeeze, to reduce the dimension. So it's 3-dimensional. We pass the first dimension inside squeeze and we'll remove that. So now it will become a 2-dimensional image, and there you go. We have the images from the Fashion MNIST dataset being plotted. But we don't actually know what the labels are corresponding to this. In order to do that, we'll have to fetch the labels from somewhere. So we'll be using the plt.title function, so it will actually put a title underneath the image that was plotted. So when we were inside Fashion MNIST, that class, we already saw the labels list, which was called classes. So the thing that we can do is easily copy this list, take it back to our previous notebook, and there, since it's a list, right, we can directly pass an index to the particular list and it will give us the label. That is exactly what we're going to do. So we're going to copy this list, we're going to take it back to our function which we had written, and yeah, so we can just paste it here, and then in the title we're just going to pass classes and the label which was written to us, because that label directly corresponds to the name of that particular apparel inside the classes list. So as you can see, I'm just passing label, and now you will see, yep, so we have sandal, ankle boot, and the labels corresponding to the images pop up as well. We'll just pass plt axis is equal to off to clean it up, and there you go. That's your Fashion MNIST, or I would say a sample from your Fashion MNIST. So the next thing that we're going to look at, or would take a glimpse of, is the Dataloader class, which is part of torch.utils.data. So Dataloader is kind of an iterator over the dataset class, and this is very important because it allows you to iterate over your entire dataset and return batches of data which is used during training. And here we are inside the Dataloader class. As you can see, one of the arguments is dataset, on which the iteration is happens, and then we have number of workers also. We can specify the number of workers which can be used to load data, and if you have a multi-core system, which is common in these cases, and so you will be able to load data faster. You can also have a pin memory device. So essentially, if you have a GPU, then you can directly load your data onto the GPU without having to load it to CPU first, and then do a 2-device as we do in PyTorch, or how we'll be seeing when we actually train a model. So first, actually, it is loaded to RAM, and then you do a 2-device. If it is a GPU, then it gets converted to a GPU. So as you can see, if you pass the CUDA device, it will automatically do that, copy the tensors onto the CUDA pin memory, And yep, so that's one of the parameters. So let's go ahead and create a data loader for our training data set and see what happens. Essentially, we're going to call it training data loader, and we're going to pass the training data set, the Fashion MNIST data set that we created. So the first argument is going to be the training data set, and the next argument is going to be the batch size, apparently. So the batch size is very important because that determines how fast a training experiment will happen, and it is also dependent on the size of the memory that you have. If your GPU is very small, then you won't be able to load a larger sized batch. So just for demonstration purposes, we're choosing a batch size of 1, and we are like putting shuffle is equal to false. If you put shuffle is equal to true for every fetch that you do from the data loader using the data loader, the data is going to get shuffled, and we don't want that, at least not for our use cases. We want a pass or an iteration, all the iterations to cover the entire data set. We don't want any duplication in any case. So since we know that it's an iterator, right, so we can just call the iter and just do a next in order to yield some of the data points. So since we have passed a batch size of 1, we're going to see what happens, like what is present inside data item, right? So as you can see, it's a list, and the first value is a tensor and the second value is a label. So we're just going to pass type, and we're going to see that it's actually a list, right? So the first value, as we saw, was a tensor, and the second value was the label, which was also a tensor. Unlike the previous get item call that we did, data loader makes sure that it is converted to tensors, because tensors are components or entities in PyTorch over which the automatic gradient calculation happens, and is differentiable, makes the entire component differentiable. So as you can see, the 0th element, the first element, had a shape of 1 because we just had one image, and if we pass batch size of 2, you will see that the first tensor which comes out, right, from data item will actually have the first dimension as 2. Because there would be 2 images. So here you can see, so the image dimension is actually 1 cross 28 cross 28. It's a tensor of 1 channel and 28 cross 28 height comma width, but there are 2 images, and that's the reason we have a torch size of shape 2, right? 2, like as in the length is 2, you can say it in that way, or there are 2 tensors of shape 1 cross 28 cross 28. We can also plot the tensor which was returned. So in order to do that, we can just do we can take the first image which was present inside data item. So here we are taking data item of 0 as the image, and then we're just going to go ahead and use the same functions which we did previously, which was plt.imshow and plt.show in order to plot it. In our case, the tensor is of shape 2, so we're going to take the first image. So instead of taking data item of 0, we'll have to take something like data item of 0 comma 0. Yep, so we're going to just do an image of 0 because that is going to return the first image to us, and we're going to squeeze it because we want to remove that third dimension, which is the channel actually. And then if you see the shape, it's 28 cross 28, which will be perfect for the PLT function, and we're just going to go and pass the same value inside plt.imshow. It's going to plot the image, and let's see what comes out. And there you go, it's a boot that we have. So yep, so that was a demonstration of what datasets are and what data loaders are. And in the next video, we're gonna build a custom dataset with one of the datasets that we download online. It will be an open source dataset, so we'll be using a dog dataset essentially, and we're gonna build our own custom data loader to see how we can load it for training purposes.